okay? And the other two are not affected. Close it. Open the switch at the bottom, and I turn off only the light at the bottom, okay? And the other two remain unaffected. Okay? So that would be very convenient in a house, for example, okay? Where when you turn off your light, okay, well, your parents' bedroom is not affected, okay? The lights there stay on, okay? Or your sister's bedroom, brother's bedroom is not affected by your action, right? So let me see if I have solved the problem. So set up a circuit with the same battery voltage as in 6. It was 9 volts. Check, still 9 volts. Fine. Where there are 3 bulbs, yes, 3, and 3 switches in this. Create this circuit such that when one switch is open, only one bulb goes out. Okay, so we've answered that problem. Now, problem number 10. Close all 3 switches and observe the brightness of the bulbs. Are the bulbs dimmer, the same, or brighter than your bulbs in 8? Okay, so basically for this 10th problem, you will have to compare the current circuit with the one that you had in problem 8. Okay, and then you will have to determine the brightness of the light bulbs. Okay. How are you going to do that? Of course, you have to use the notions from your lectures. Alright, so that's it with the problem number 10, but there are 2 remaining problems. So we need to now build the following circuits. And then use a voltmeter to get your readings for voltage across circuit components, and an ammeter to measure current in circuit branches. So determine by calculation, so here you will have to make actual calculations on paper. So determine by calculation values for those meter readings you took, and compare meter values to calculated values. Are there any differences between these 2 values? Record your data in a table. Are there any current and voltage laws applicable to your circuits? Name those applicable laws. Alright, so let's start with the first circuit. That's very easy to do. Let me get rid of the current one. Yeah, we have to get rid of it. So what do we need? So we need a 12-volt battery. So battery is here. To the top, we need a 4-ohm resistor. Resistor is here. Okay, but it's connected to the negative terminal of the battery. If you don't remember which one is negative, which one is positive, then go back to the symbol in the bottom right part of the screen. Click on it, and then it will tell you, okay? By convention, this is the positive terminal, this is the negative terminal, so you see that this resistor is connected with the negative terminal. Okay. Then what comes next? Need a wire and 2 resistors connected in series. This is it. current is flowing because you have a battery. But then there is a third resistor here, okay, and I need to connect it with the rest of the circuit. Okay. Using wires, of course. But these resistors do not have the same resistance. This one has a resistance of 5 ohms. So this, for example, 5. The one here on the right has a resistance of 7 ohms. Okay. The one at the bottom has a resistance of 10 ohms. Okay, I already have 10. And this one here on the left has a resistance of 4 ohms. That's 4. So that's it. Okay. Okay. If I go back to the problem, build the following circuit. Use a voltmeter to get your readings for voltage across circuit components, and an ammeter to measure current in circuit branches. Determine. So you basically have to compare the calculated values from the values obtained by using the instruments. One thing you have to remember, of course, is that the voltmeter doesn't go in the circuit, okay? You just place the leads wherever you need to make a reading. The voltage across this resistor, for example, I find it to be 2.16 volts. Oh, I forgot to change the voltage of the battery. So the problem says that the voltage must be 12 volts. Alright, 12 volts. Now I found a voltage of 2.88 volts. Okay? For this other resistor, the resistor on the right, and in the middle branch of the circuit, I found the voltage to be 4.04 volts. Okay? And you can do that for the other parts, the other pieces of the circuit. But now, how about the current? How do you measure the current? Well, as I showed you in the other circuits, for the problems above, you have to take the ammeter and place it in the circuit. Okay? If you want to know the current that flows, okay, let me get the conventional current. I prefer the conventional current. The current that flows through this resistor at the bottom, so you need to make a cut and place the ammeter there. Okay, and I read 0.69 ampere. If you want to know the current that flows through this resistor, you need to make a cut, okay, and place an ammeter there. Okay. Notice how it says 0.86 ampere, okay? But however, when I connect this other piece, it changes, doesn't it? It changes. To 1.27 amperes. Okay? Quite interesting. Okay. By consulting your notebook, you will know why, of course. And then you can connect ammeters to other pieces of the circuit and read the current there. Alright, and then there's another circuit that you have to set up, and which will be the last circuit, but I'm not going to do that. You'll do it yourselves. Alright, I hope this helps. If you have questions, please send me an email, and I will be glad to help and to answer your questions. Thank you, and see you next time.